Alright, this tutorial is going to take it a step farther. We just learned how to graph, and I'm going to use a graph that we've already created on the previous tutorial and show how can I show the solution algebraically. Because that's what we've been doing. We find in a table, a lot of times you can actually see a solution in a table. We put it on a graph. Sometimes you get whole number inputs on a graph, but you want to be able to check it another way. Algebra also helps you solve it for when it's not hidden cleanly, which we have not talked about with quadratics yet. So right now we just want to confirm the ones that we can already see in the table. So we can see that, it's 7 in the table at 8 and 0. So that first problem here, we want to get 8 and 0 as our answers. We see in the table that x, this is equal to 0 at 7 and 1. We want to be able to see that. This one's not in the table, but it is between these two. Right, so we should get an answer that's between 1 and 3, between 5 and 7. Right, negative 8, we can see in the table, is 3 and 5. Negative 9, it's only 4. But why is it only 4? Right, so we're going to look at it algebraically, as well as how it's connected to the graph. So if I look at it graphically, I'm going to just add a line. Right, this would be the line with the constant of just, maybe g of x equals 7. Well, that's true at the points 0, 7, and 8, 7, right? It shows up on the table and the graph now. Right, so this graph, if we just show it algebraically, the problem is that there's multiple things that multiply to 7. There's 7 and 1, but there's also 2 and 7.5, 3 and 2 and a third, 4 and 1 and 3/4, etc., etc. There's an infinite amount of possibilities. So what we actually want to do is limit the number of possibilities. Which, to do that, let's talk about this one with 0 real quick. 0 has a special property of its product. When you have a product of 0, there's actually a very limited amount of options. I mean, it's still infinite combinations, but okay, let's list the things that multiply to 0. There's 1 and 0, 2 and 0, 3 and 0, 4 and 0, 5 and 0. Right? There's some consistency, or I can say there's 0 and 1, 0 and 2, 0 and 3, 0 and 4. Whatever factor pair I have for 0 is one of them has to be 0. So we know that either this first factor is 0 or the second one is. This one's really easy because it's already set equal to 0. Right? This would have to be x is either 7, because 7 minus 7 is 0, or x minus 1 is 1, because 1 minus 1 is 0. Right? So when this right side is 0, we can solve these rather quickly. But this is not 0. So we want this to become 0. So if I subtract 7 on both sides, that makes that 0, but I don't have anything to combine it with. So we're going to have to change this form so we can subtract 7. And then after we've subtracted 7, we need to get it back to factored form to solve it. So let's see what that looks like. If I distribute, I get x squared. No problem there. X times negative 1, I get minus 1x. Negative 7 times x, I get minus 7x. Negative 7 times negative 1, I get plus 7. All right, and this whole thing is equal to 7. So I get x squared minus 8x plus 7 is equal to 7. Then we want to set that equal to 0, so we're going to subtract 7. Something weird happens on this one. It's not the best looking 7 in the world. All right, because that's going to cancel out. I'm going to get x squared minus 8x plus 0 equals 0. All right, I'm going to make some room here, so I'm going to get rid of that real quick. All right, well, if we look at how this trinomial relates to it in factored form, this third number, the constant term, is just the two numbers multiplied together. The middle number is the sum of these two numbers, negative 1 and 7. So we're looking for two numbers that sum to negative 8, but they add to 0. The only way you're going to get something to do that is if, well, to add to 0, you're going to have to be the same number but opposite signs. Well, the only number that could be the same number and opposite sides, it would have to be, 4 and negative 4, 5 and negative 5, 6 and negative 6, right? Those things would add to 0. We're trying to multiply to 0, so that means it'd have to be like 2 times 0, 3 times 0, 4 times 0. So one of them has to be 0. So that means that our factor pairs would be x plus 0 has to be one of them because I'm multiplying to 0. Well, it has to add to negative 8, so that means it'd have to be x minus 8. All right, so that'd be x minus 8. All right, and these equal 0. All right, so either x plus 0 is 0. Well, make that be true. X is 0. Or x minus 8 is 0, which for that to be true, x is 8. So for that problem, 0 or 8 would make it 7. Well, that's what we knew the solution to be anyways. If you look on this left side, right, 0 and 8 are what gave us 7. So, right, we just confirmed what we already knew. All right, and we can continue this process. So just for making space, I'm going to move these problems to the side for now. And we're going to do the same thing. We're going to distribute. Then we're going to move the term on the right to the left to set it equal to 0. And finally, we'll have to factor it back out in order to solve. Right, because we want the right. The big thing is that our initial goal is to get this to be 0 so that we can get something in factored form to solve. But I can't get rid of it at the beginning because this is still in factored form. So x times x, I get x squared. Right, x times negative 1, I get minus 1x. Negative 7 times x, I get minus 7x. And negative 7 times negative 1, so I get plus 7. All right, and this is the same thing we already got before, equals negative 5. All right, and that's not going to change on the next two problems either, so in the future, we'll just be able to jump straight to the trinomial. There's no reason to need to do that twice, 3 times, or 4 times, or 5 times. All right, so this is going to be, again, x squared minus 8x plus 7 equals negative 5. And then we're going to add 5 on both sides to set it equal to 0. And that's going to give us 12 as our C term. So now we're looking for things that add to negative 8, but sum to make 12. Right, well, there's an infinite combinations that sum to negative 8. There's 1 and negative 9, 2 and negative 10, 3 and negative 11, 4 and negative 12, and so on and so on. So instead, we're going to list the possibilities that multiply to 12, specifically the negative combinations because we're trying to add to a negative. So if I list the possibilities that multiply to 12, well, all I have is negative 1 and negative 12. I have negative 2 and negative 6. And I have negative 3 and negative 4. And negative 2 and negative 6 is the only combination that sums to negative 8. So this would factor as x minus 2 times x minus 6 equals 0. All right, so x would have to equal 2, and x would equal 6. All right, so can't confirm that one in the table because we can't see it. All right, but if we put 2 here and negative 5 in the table, we put 6 here, negative 5 in the table, it would make sense. We can move that line right down to negative 5. So let's see, negative 1, 2, 3, 4, 5. Right, and they intersect at 2 and 5. Right, these last two we can check in the table. So at negative 8, we should be getting 3 and 5. At negative 9, we should be getting 1 and 7. So you can try those last two on your own to see if you're able to do it without